Okay, I told you that we were going to learn how to factor several different ways. We have the greatest common factor. We have factoring trinomials where a is 1, and then factoring trinomials where a is not 1. The last kind these are special cases. They're unique, and you should be able to recognize them without actually having to factor. You should look at them and say, hey, I recognize there's something going on here. Okay? So the first kind is perfect squares. We mentioned this the other day that once in a while you're going to see perfect squares. What I mean by perfect squares is the first and last term are perfect squares. Okay, do you notice how each one of these are perfect squares? Okay, when I see that, my instinct is just to say, what's the square root of x squared? X. What's the square root of 1? 1. And these are both going to be the same. X plus 1, x plus 1. Okay? Check it. If you multiply this, you end up with x squared plus x plus x plus 1, which is x squared plus 2x plus 1. Okay, let's try the next one. Do you see the perfect squares? A squared, a and a, 9, 3 and 3. Okay, remember I told you this won't always work, but boy, it sure does a lot, like most of the time. Okay, let's check the next one. X to the 4. Is that a perfect square? Yes, it is, because x squared times x squared is x to the 4th. And 100? 10 and 10? Plus, plus. Okay. Next one. By the way, what if you didn't recognize that it was perfect squares? Could you do this just factoring them regularly? Of course. Yes, you could. Okay, but hopefully as you do enough of these, you start to recognize the perfect squares. And just so you know, your textbook or answer keys, if you're doing any of this stuff online, will often write this like this. Okay? Either way is fine. Doesn't matter. Okay. 144x squared, 12x, 12x, 1, 1 and 1. Okay. Every one of these you should be checking, but you should see that these are correct. So I have 5x, 5x, plus 2y, plus 2y. Okay, quick mental check. 5x times 5x is 25x squared. Outside's 10xy, inside 10xy. That gives me my 20xy. Okay. One more. 4x, 4x, plus 5, plus 5. Alright, so that's perfect squares. And then we're going to see something called difference of squares. Remember when we were foiling this, and I showed you that when you have conjugates, one's positive, one's negative, that the middle terms disappear? Okay? If you were multiplying this, you would end up with x squared plus xy minus y squared, and these middle terms cancel out. Alright? That's called difference of squares. Okay. This is the easiest factoring you're going to do if you recognize it. How do I know it's a difference of squares? Well, perfect square, perfect square. And there must be a minus sign in the middle. That's why it's called difference of squares. Okay, if that's the case, we know these are conjugates. We know that we can take the perfect squares, and one is positive, one is negative. Okay, check that. You'll see that it works. Okay, let's do this one. Is this difference of squares? Perfect square, perfect square. Difference. Yes, this works. So I should be able to go x and x, 4 and 4, one's positive, one's negative. Okay, let's keep going. Perfect square, perfect square, positive, negative. Okay. Just want to highlight to you, remember to always greatest common factor first. Why do I say that? Is there a common factor here? Should see that there is a 9 that can come out first. Okay, so I'll leave the 9 there, and now these are difference of squares. So I can go 2m minus 3n plus 3n. Okay? Next one. Is this a difference of square question? Is this a perfect square? Some of you are saying, no, 10 is not a perfect square. But remember what m to the 10 means. It means m 10 times. All right, and that means you could have m to the 5 and m to the 5 as your two factors. So it is a perfect square. M to the 5, m to the 5. Minus x to the 4 plus x to the 4. And again, just so you're aware, this plus or minus, I could reverse those, right? I could go negative here or I could go plus here. Doesn't matter, as long as they're alternating. Okay, trick question. You know, us math teachers, we do have our book of things or ways to trick students. Do you think this question is going to be on the test if I'm telling you right now this is the way I trick you? Well, I mentioned that I can trick you another way too, but really common mistakes people make. These always show up on tests. This one, there's a good chance this will show up, and it is a trick question. Let's see if you catch it. Go ahead and try it and see if I can trick you or not. Okay, so perfect square, perfect square. So did you go x squared and x squared? And did you go plus 1 minus 1 like that? Did you get that? Well, you would get 1 out of 2 marks because you're right, but not completely right. All right, and the reason for that is we can factor this further. Look what you see there. Okay. Here, I can't do anything with this. But the second one is difference of squares again. They're both perfect squares, and there is a subtraction sign. So I can go x times x plus 1 minus 1. Why did I not do that here? Because it's not a difference of squares. This one is plus. Okay? Just for interest's sake, is there a way that you can factor this? Can you go x plus 1 and x plus 1 instead of the minus? Well, if you multiply that out, you get x squared plus 2x plus 1. That doesn't equal this. Okay, so this can only one of them can be factored a second time. Trick question, you guys. For sure it's going to show up. Okay, your homework. Exercise 7.